All right, let's get right into it. We're going to talk about a cosmic mystery that completely stumped some of the greatest minds of the 20th century. And, in the end, it totally shattered our understanding of reality itself.
So, our story really kicks off with a phenomenon so bizarre, so utterly strange, that Albert Einstein had the perfect name for it: spooky action at a distance.
You see, for Einstein, the universe was this beautiful, orderly, predictable machine, a grand clockwork, right? But this new theory, quantum mechanics, came along and it suggested that at its core, the universe was based on chance and probability. And that deeply, deeply bothered him. He just couldn't get on board with the idea.
And this wild new prediction had a name: quantum entanglement. It describes this, almost magical connection between particles. They become linked, acting like a single entity, even if they're on opposite sides of the galaxy. Their fates are tied together. Okay, to wrap your head around this, picture it like this. Imagine you've got two marbles, one black and one white. They're a matched set. You stick them in two separate boxes, you don't peek, and you mail one of those boxes to the moon. The second you open your box here on Earth and see that you have the white marble, you know instantly that the one on the moon has to be black.
And that is the billion-dollar question, isn't it? How in the world does that marble on the moon know what happened back on Earth? This weird connection seems to happen instantly, which would mean it's breaking the ultimate speed limit in the universe, the speed of light. And nothing is supposed to do that.
So this whole cosmic puzzle basically created two competing theories for what reality is really like. Two main suspects in the case, if you will.
Okay, so on one side, you've got Einstein's view, which we call local realism. It's the common sense approach. He said, look, the marbles had their colors from the very beginning. We just didn't know which was which until we looked. Simple. But then, on the other side, you have the wacky world of quantum mechanics. It claimed the marbles were neither black nor white. They were in some weird, fuzzy state of all possibilities at once, right up until the moment someone looked.
So let's just quickly define these terms, because they're crucial. Realism is the idea that stuff has definite properties even when we're not looking. You know, the moon is still there when you close your eyes. Locality means nothing can affect something else faster than the speed of light. So Einstein believed the universe was both local and real. He thought the particles had some kind of hidden plan that decided their properties from the start.
Now, for decades, this was just talk, a huge philosophical argument between the biggest brains in physics. But then, in 1964, a brilliant physicist decided to stop arguing and start testing. He stepped in to play detective.
His name was John Bell, and what he did was, frankly, genius. He figured out a way to take this philosophical head-scratcher and turn it into an actual experiment. He found a way to ask the universe directly, hey, are you playing by Einstein's rules, or is this quantum stuff for real?
He came up with this amazing mathematical test, basically a line in the sand for reality. He proved that if the universe was local and real, like Einstein thought, then the results of these experiments on entangled particles couldn't go past a certain point. But if quantum mechanics was right, the results would cross that line.
And so the race was on. Over the next 40 years, physicists like John Clauser, Alain Aspect, and Anton Zeilinger, who, by the way, won a Nobel Prize for this very work, put Bell's test into practice, getting more and more precise over time.
And the results, well, they were absolutely conclusive. Just look at this graph. As the experiments got better and better, what happened? The red line goes up and up, showing more and more violations of Einstein's rules. Time after time, the experiments proved it. Reality consistently breaks Bell's inequality. The connection between the particles was way stronger than Einstein's common-sense rules could ever allow.
So the verdict was in. The universe simply does not follow Einstein's rules. His legendary intuition, which gave us general relativity and completely changed how we see space and time, for once, it was wrong. Okay, so if our universe isn't locally real, then what in the world does that mean for us? What kind of bizarre reality are we actually left with?
Now this is where it gets really mind-bending. The experiments force us into a corner. We now know for a fact that the universe cannot be both local and real at the same time. We have to pick one to throw out. One of these bedrock assumptions about reality has got to go.
Let that just sink in for a second. We have to discard at least one of the most basic, common-sense ideas about how the world works. The universe is either not real in the way we think of it, or it's not local. There's no third option.
So let's say we ditch realism. What does that mean? It means our quantum marble truly has no color. It's not black, it's not white, it's nothing definite, until the exact moment we measure it and force it to pick a side. Its properties literally don't exist until they're observed.
Okay, but what if we keep realism and instead we throw out locality? Well, then that means the spooky stuff is real. It means there is some kind of instantaneous, faster-than-light connection linking things across the cosmos. We just have no idea how it works.
So yeah, the verdict from Bell's test is in, but the mystery of what reality is has only gotten deeper. We've proven that the universe is profoundly stranger than we ever could have imagined, and it forces us to ask a pretty humbling question. If we were that wrong about something so fundamental, what else are we getting wrong?